Hello, good evening everyone. Good evening everyone. I welcome all of you to the most comprehensive exam preparation app that is BYJU'S app on YouTube. Okay, so let us start now. All of you please join fast. Please do not forget to share and like. Please hit the like button and share it. Let others also know and join. And quickly we'll start our practice on matrix method problems. So morning session I told you how to generate the stiffness and flexibility matrix. How to generate the stiffness and flexibility matrix. Hello GK. When we have to take sine and cos theta, for which problem you are asking, you just see, uh, do one thing. This problem you just click a photo or just type there in my telegram channel. I'll let you know for which problem what exactly you are trying to ask. I'm not able to understand that, so please ask there. Okay, all of you please share it and do not forget to hit the like button. Right now let us start. I hope I'm audible to all of you. This is my small introduction, and all of you please join me in the telegram channel that is civil by Ansari sir. Right, let us start now. There is a 25% off flat going on. You can avail it by using the code that is extra 25. This is a September special and it will be only remaining for till tomorrow, I think. Right, so let us solve the problem first, and here is the first problem in front of you. Can you tell me which one is the correct one? Hello Rajiv. Which of the following are correct for the flexibility method? Which of the following are correct for the flexibility method? It is used when degree of static indeterminacy is less than kinematic one. Elements in the flexibility matrix shows deflection. F12 represents displacement at coordinate 1 due to the unit load applied at coordinate 2. And first column of the flexibility matrix represents displacement. Now, first one already we have discussed, right? You have a force method and displacement method. We have a force and displacement method, right? Whenever we have a degree of static intensity less than kinematic one, we are actually implementing the force method. Flexibility method is nothing but your force method. That then it is correct one. It is correct one. Then element in the flexibility matrix shows the deflection. This is also I told you the flexibility definition, right? By providing a unit force, you are actually identifying the displacement or deflection at other coordinates. So all the flexibility matrix element, the element in the flexibility matrix are nothing but showing displacement at different coordinate due to the unit load applied at coordinate, right? If you are applying morning only I told you, suppose this is the column, first column I'm talking about. Here displacement in the coordinate 1 and displacement in the coordinate 2 due to the unit load applied at coordinate 1 itself, right? All the element in the flexibility matrix are nothing but your displacement or deflection. This is also correct. Then F12 represents the displacement at one coordinate due to the unit load applied at coordinate 2. This is also correct. F12 represents, this is the definition of F12. F12 displacement at coordinate 1 and due to the coordinate unit load applied at 2. First column of the flexibility matrix represents displacement of all coordinate due to the unit load applied at coordinate 1. That is also true. Here all are correct. All are correct. I hope I have already explained it in the morning session, right? I have already explained it in the morning session. Now next one. Which one of the true for stiffness matrix if I'll consider L equals to 4 meter? If I'll consider L equals to 4 meter, which of the option is correct one? Which of the option is correct actually? Which of the option is correct? Can you do this one? Can you do this one? This was the question I gave you in the morning, and I told you that we will be solving in the at 9 p.m. right? At 9 p.m. Now, to generate the stiffness matrix, for the given coordinate 1 and 2, what we are going to do here, if you want to generate the first column and second column, because only 2 by 2 matrix you will be getting for the 2 coordinate system, so just generate it for the first column and second column, right? So stiffness matrix, if you want to generate, see, first column is what? You apply the unit displacement in the coordinate 1 direction, that is the moment you are going to apply in the coordinate 1. If you apply the moment in the coordinate 1 and restraining the rotation of, or restraining the other displacement which is given in this coordinate 2, what exactly you will be doing here? So apply the unit displacement here, that is unit rotation actually, in the coordinate direction 1. As you have a other coordinate is the rotation, so just stop that rotation here and find it out. If you are producing a unit rotation at this location, what will be your force? Which is going to generate in the coordinates? So now this will become like a propped cantilever, isn't it? This will become like a propped cantilever. Now what is the force which is going to generate in the coordinate direction 1 and coordinate direction 2? The force which is generating in the coordinate direction 1 and 2. This is your coordinate 1 and this is your coordinate 2. If you want to generate a theta here, that theta at A, you know that it is nothing but theta at A is nothing but what? ml by 4 EI. ml by 4 EI, isn't it? Or I can say that m is nothing but 4 EI by L into theta A. Now to provide a rotation at 1, you have to you will get the moment of 4 EI by L here. So theta, if theta is 1, you'll get 4 EI by L at A. At A, you will get force, that is moment, nothing but 4 EI by L. And far end, if it is fixed, half of the moment will be carried forward with the same orientation. If it is clockwise, a clockwise moment you will be getting it here with the value of 2 EI by L. With the value of 2 EI by L. With the value 2 EI by L. Now from here, what you will get here? K11, the force generated in the coordinate direction 1, which is nothing but 4 EI by L. L, if it is given as 4 meter, you are going to get, that is EI. And K21, in the coordinate direction 2, the moment generated due to the unit rotation provided in coordinate direction 1 is nothing but 2 EI by L. Or I can say that it is nothing but 0.5 EI, because L is 4 only, it will become 0.5 EI. Right? Now if you generate for the second column, if you generate the second column matrix can be generated. So stop the rotation here, that is on other coordinates, just you restrain it and provide the moment, or just produce the unit rotation at the mid one. Now see carefully what kind of deflected shape you have to give. If you want to rotate the joint B by 1 unit or whatever that, see, you are actually trying to rotate both the beam AB and BC. So whatever the moment you are going to provide theta, to get the theta here, that is unit rotation, how much effort you need to apply to provide theta here, to get the theta here, how much effort you will be applying here. So the effort total will become, now this is your propped cantilever. So separately you can just understand this, you can separate it and understand that. First one, that is AB, to rotate this by the amount of some theta, you need to apply 4 EI by L into theta, or if theta is 1, the effort or moment which is needed here is nothing but 4 EI by L. Similarly, to rotate this one also by unit, you need 4 EI by L. So total effort here total moment which you need to apply here to get the unit complete rotation at the joint B is nothing but 4 EI by L here for this beam and 4 EI by L. Length of the beam is already 4, so you'll get EI plus EI, which is nothing but 2 EI. 2 EI. So you will get K, see K12 already you have that K12 as per Maxwell reciprocal, I can simply write it on 0.5 EI, and K22 which is nothing but 8 EI, 4 plus 4, 8 EI by 4 EI, 8 EI by L. So it will become how much? 8 EI by L, which is nothing but L is 4, so you'll get 2 EI. 2 EI. Hence he was asking which one of the true for the stiffness matrix. I just forget to ask which element I'm asking about. Element, just I forget to ask here. Actually I was asking about K22. So K22 you will get it 2 EI. 2 EI. 2 EI. Do you get that? Now, cross-sectional area of the both steel bar of 20 mm square is given. Develop the flexibility matrix for the given coordinates. Here you have a coordinate 1 and coordinate 2 at C. What will be the flexibility matrix? What will be the flexibility matrix here? Can you do this? Can you do this one? What will be the, which one is showing the flexibility matrix here? Which one is showing you the flexibility matrix here? To get the flexibility matrix, first of all, find it out. If I'm going to apply the unit load at B, what is the deflection? What is the deflection of the AB? So B joint, how much it will be deflected? First of all, if I'm applying a unit load, what is the deflection for AB? So let's find out deflection of AB or delta of AB due to the unit load which I'm going to apply at. So delta of AB is simply I'm identifying when I'm applying the load at B itself. So deflection at B when the load I'm applying at B. What will be that one? Delta is nothing but PL by AE, isn't it? PL by AE. And P, if I'm applying 1, it will be simply length of the beam is 1, so it is 1000 mm and divided by cross-sectional area is given as 20 mm square. Then Young's modulus is given as 200 kilonewton per mm square. And you will get here you will get 0.25 right mm per kilonewton, 0.25 mm per kilonewton. That is your flexible. No, actually this is the displacement for providing 1 unit load at B. Now if I'm providing a unit load at C, that is in coordinate direction 2, unit load if I'm providing at C, by simply assuming that just assuming that only what will be the only deflection for the BC, only deflection for the BC, what will be the deflection for BC? So deflection for BC, deflection of BC member, if I'm providing a unit load, only for the unit load the deflection of the BC member will be PL by AE. Once again, P is 1, length of the member is 2000 mm divided by AE, that's L by AE. A is same and this is also 200 and you'll get 0.5. Now to develop the flexibility matrix, what will be the flexibility matrix here? See, F11, F21, F12 and F22. What is the meaning of F11? Tell me, what is the meaning of F11? Displacement at 1 due to the unit load applied at 1. So if you are going to apply the unit load at 1, the displacement of joint B, displacement of this joint will be how much? 0.25. Now 0.25 Then what is the meaning of F21? F21. If you are going to provide the unit load at 1, what is the displacement of the joint C in the coordinate direction 2? The displacement will be once again only 0.25. Simply if you are providing the unit load at 1, AB will get elongated, and due to that you will get 0.25 displacement of the joint C, that is 0.25. As you are saying F21, from the Maxwell reciprocal theorem I can simply write down F12 is equals to F21. Now what about F22? If you are providing a unit load at C, what will be the displacement at C in that coordinate direction 2? If I am going to provide the unit load at C, the total displacement will be nothing but the displacement of joint B, that is 0.25, and the displacement of joint C, that is 0.5. So total displacement here will be 0.75 of the joint C when I am applying a unit load. When I am applying the unit load at C in the coordinate direction 2, that is the total displacement. Now this is the actually flexibility matrix of your given system. This is the flexibility matrix for your given system. Did you get that? Hence option A is correct. Next one. Which of the following element of stiffness matrix are written correctly for the given structure? For the given one, which one is correct here? Which one is correct here? Now, if you want to generate the stiffness matrix for this one, what exactly you are going to do here? You have a two coordinate, that is coordinate 1 and 2. First of all, generate the first column. So seize the other coordinates and provide the unit displacement in the coordinate direction 1. If you will provide the unit displacement in the coordinate direction 1, what exactly you are going to get here? What exactly you are going to get here? So provide the unit displacement in the coordinate direction 1, and I'll just do it. Okay. Suppose this was the B. Provide the unit displacement in the coordinate direction 1, and this is the deflected shape of the frame, right? So you are restraining the rotation, which is other coordinate, that is coordinate direction 2, restraining the rotation, and simply you are providing the unit displacement in the coordinate direction 1. Now if you are providing a unit displacement, what is the reaction or forces which are going to generate? Just let's see that. Due to the sway of that, if it is delta, you are going to provide 1, right? Delta. Then a moment, see, if it is rotating clockwise, anti-clockwise moment will get generate both the support. Anti-clockwise moment will generate at both the support, right? The value of the anti-clockwise moment, you already know that 6 EI delta by L square. So 6 EI delta, if it is given as 1, we are providing unit displacement. So 6 EI 1 divided by L square, 6 EI delta by L square. Here also 6 EI delta by L square. At the same time, what will be the reaction here? What will be the reaction here? So reaction, if you will calculate, reaction will be, you will be getting reaction if you have a anti-clockwise net moment. A clockwise moment will be generated by the reaction. A clockwise moment will be generated by the reaction, isn't it? Now you have a reaction which is generating a clockwise moment to oppose the anti-clockwise moment. Are you able to understand that? And this is clockwise, this is anti-clockwise, and reaction will be 12 EI delta is 1 by L cube, 12 EI by L cube, right? Now what is the value of K11? K11 is nothing but your 12 EI by K11 is nothing but 12 EI by, isn't it? 12 EI by L cube. Then what will be the value of k21? That is in the direction of coordinate 2, it is -1. It is -1, and it is nothing but 6 ei. It is nothing but 6 ei by k21, 6 ei by L square, 6 ei by L square. Then k12 of course will be same and is that as. Now go for the deformation, that displacement you provide in the coordinate direction 2, displacement you provide to get the k22 value, to get the k22 value. Now the displacement will be seized here or restrained. By restraining the displacement, if I am just providing the rotation here at this point, if you want to provide the rotation at this point, so simply if you want to provide the rotation, what will happen here? Suppose providing the rotation in the coordinate direction 2. So to produce unit rotation here, this is the deflected shape of the beam. To produce unit rotation, far end is hinged, so here you need to apply 3 ei by L, 3 ei by L, and here you need to apply 4 ei by L, 4 ei by L, 3 ei by L and 4 ei by L. So total effort which you need to apply here, is nothing but k22, the moment which you need to apply to get the unit rotation of the joint, of this joint, unit rotation of this joint is nothing but 7 ei by L. So k22 is 7 ei by L. Now you just check it out. The 2 by 2 matrix will be generated for this coordinate. Yes, if it is 2, you will get 2 by 2 matrix. K11 is absolutely wrong, 12 ei by L cube. K12 is minus of 7. This is also wrong. It is actually minus of 6 ei by L square. Then K22, yes, it is correct one, 7 ei by L. So here 1 and 4 is only correct. Option is not given. 1 and 4 are correct only. Maybe it is 1 and 4. Right? These are the only correct value here. Did you get that? All of you, please do not forget to hit the like button and do not forget to share it along with your friends. Okay, move for the next problem. Which of them is giving the correct value of F11? Which of them are giving the correct value of F11 from the flexibility matrix? Can you calculate? From the flexibility matrix, which of them are giving the value of F11? How will you do this one? So here, once again, you have to generate the flexibility matrix, that is F1. What is the meaning of F11? Displacement at coordinate 1 due to the unit force provided at coordinate 1 itself. Displacement in coordinate 1 direction due to the unit force provided in the coordinate direction 1. Now, if you are going to provide the unit force in the coordinate direction 1, what exactly will happen here? Now, providing the unit force in the coordinate direction 1, what is the displacement? What is the displacement. So we want to generate the flexibility matrix for this one, right? Now suppose if I'm providing unit kilonewton load, what will happen here? What will happen? The unit kilonewton load is going to produce delta. Now that displacement I'm more interested about, so I'm just providing unit kilonewton. Due to the unit kilonewton, how will write it down? Due to the unit kilonewton, a reaction which will be generated at this location will be 12 EI delta by L cube, 12 EI delta by L cube, and here also you will be getting, suppose I'll say L1 cube and 12 EI delta by L2 cube, because only the length of the beam are different, length of the column are different, right? So what is the total force I'm applying? That total force I'm applying is 1 kilonewton, which is equivalent to 12 EI delta by 4 cube plus 12 EI delta by 2 cube. 12 EI delta by 4 cube plus 12 EI delta by 2 cube. If I'm producing a delta deformation due to the unit kilonewton load, 1 kilonewton I'm just providing here, right? Now calculate the delta from here. Delta, if you take common, कितना बचेगा ये? 12. Okay, wait. So 1 equals to, you take EI delta, 12 EI delta if you take common, then you'll get 12 divided by plus 12 divided by 2 into 2 into 2, 2 2 4 3 12, 3 बटा 2 और इधर 4 3 12, 3 बटा 12. So how much will be getting? Oh, it is in point, no? So okay, let it be. No, this 4 3 12 16 और 2 16. Just a moment. 3 plus 8 8 24, 27 by 16. Is it 27 by 16? By 16. Can you just calculate this one? EI delta, if you take common, 12 by, it was correct one only, I think, right? 27 by 16 I got, no? 27 by 16, so EI delta, so delta will become 27 by 16. So 27 by 16, so delta will become 16 by 27 EI. And how much is that 16 by 27? 16 by 27 is 0.59. Yes. Did you get that? That is the delta you have. That is the delta you have here. It was correct only, huh? So delta you take common from here, then you just do a little bit calculation, that's all. Now, what about this one? Compute the translation stiffness of joint B, the horizontal direction of the rigid jointed frame in figure. What will be that? Can you calculate this one? How you will calculate? If you want to provide the, see, he's asking simply the translation stiffness, means if you want to produce the unit deflection, if you want to produce the unit deflection at B in the given coordinate direction 1, if you want to produce the unit deflection, that unit translation of B joint in the given coordinate direction, that is in the coordinate direction 1, how much force you need to apply? That is the meaning. That is the meaning. How much force you need to apply? Can you just do that? Can you just do that? How you will be doing this? All right. Write it down. How much force you need to apply? Okay. Before that, where is that my, if you are going to provide some force here, what kind of deflected shape you are going to obtain here? The deflected shape which you are going to obtain here is to produce a unit to produce the unit displacement, how much force you need to apply. So unit displacement must be produced for all the position, right? It must be produced for all the position, right? Now you write it down one by one and then calculate it. That's all. So here for individual, if you conduct individual, that for CB, the length for CB is 3, but the problem is that for the length ED you have a 2i. Now I'll consider for the CB 12 EI by 12 EI delta by L cube. Now delta, if I am producing one deformation, one deflection, that is one translation, 12 EI delta by L cube. So 12 EI by L cube, I will write down one by one all of them. 12 EI by L cube, that L is 3 cube. This is for CB I have written. Now I'll write down for AB. So instead of writing down AB, I'll just multiply by 2, because here once again 12 EI by L cube, same L3 it is here, right? Then I'll write it down for GH. So here I'll be providing you for the 3. See, for the GH also it has only same moment of inertia. So I can write down 12 EI by L cube. L is only 3. So all these 3 member I have considered now. All the 3 I have considered here. So I'll just multiply with the 3. Multiply with the 3. Then plus what remains? For DE, 12 EI is actually 2 EI. EI is 2 EI. 12 2 EI. 12 EI by L cube. L cube is still 3. 3 cube. Then this is also considered. For EF, it is 12 EI. EI is okay. Once again 2 EI, 12 EI by L cube. This is 4 cube. Then plus. So this is also done. HI, for the HI if I write down, that is 12 EI. EI is only I. So 12 EI by L cube. L is 5 meter. 5 meter. Add all this. That's all. Add all this. Add all this, how much you are going to get here. So this is 3 plus, actually 12 EI, no. So 3 plus 2 is 5 bar 60 by 27 EI. I'm just simplifying this, and here you'll get how much? 6 by 16 EI, and then plus this is simply 12 by 25. That's all. You just do the calculation and you will end with the value. See, 60 by 27, this one. Just do the calculation, how much you are getting it. This is 12 by 125. You will end with this value, 2.69 of EI. Did you get that? Now, which of them is correct? Which of them is giving correct value of F13 from the flexibility matrix if the length of the beam is given as 6 meter? If the length of the beam is given as 6 meter, which one is correct here? How you will do this one? F13. To get the F13, what procedure you will adopt? To get the F13, what exactly you will do? What is the meaning of F13? The displacement of one coordinate. If you are providing the, if you are just providing the rotation in the coordinate, sorry, unit force, that is unit moment, if you are going to provide at coordinate third, then what is the slope at 1? That is the meaning. That's the meaning, right? How you will get this one? How you will get this one? Generally we remember for the if you are see, generally we used to remember it is not mandatory that whenever it is asked for F31 you will be doing for F31 only. You can calculate for F13 also if you are feeling comfortable for F13, because from the flexibility from the Maxwell reciprocal theorem, of course the displacement at 1 due to 3 or displacement at third due to 1, both are same, right? F13 equals to F31. So instead of if I'm calculating for F1 F31, it will be slightly, generally we don't used to remember that. Now provide the unit moment at 1, and then find it out what is the rotation at third one. That can be done. What is the theta at third? If suppose this is L by 2 and this is also L by 2, if I'm providing a unit moment here, what is the theta which is going to generate at B? That is what I am more interested here. Once I'll get the F31, I'll say that F13 and F131 are same, no? As per Maxwell reciprocal theorem, I can say that F13 equals to F31. Now, as you are going to provide unit moment here, what is the theta you will be developing? What is the theta you will be developing here? First of all, try to identify, separate it. These two beams are, just you separate these two and let me know how much theta you can produce by the some moment. If you want to provide some moment here, this is M, how much theta you will be able to create here. So separate these into two separate. It is your choice. If you can do it here only, it is okay. Suppose instead of separating it, if you are just providing a moment here, this is the kind of deflected shape which you are going to get it here. 2. What will be this theta? I'm asking you. What will be this theta due to that moment? Can you tell me? So this can be done by single piece. That's what I'm telling you. Generally we used to remember it. If I'm going to provide a moment here, what will be the theta at this location? This theta is nothing but ml by 3ei. Now due to this joint and similar, both the beams have a similar stiffness, that AC and CB have a similar stiffness, so m will be divided by m by 2. Correct, no? Now this theta, this is L by 2. Can you tell me what is the theta here? The theta will become ml by 3ei. That is nothing but m L by 3ei. Are you able to understand that? And certainly it will become 3/12. No. ml by, am I producing here ml by 3ei? Yes, it will be theta here will be ml by 3/12. Okay, 12ei. And what will be the theta at this location? That theta at A. This is theta at C only. What is the theta at A? Theta at A will be nothing but ml by 6ei. M L by 6ei. And it will be ml by 24ei. This is similar to this one. Here also theta B you will get it nothing but ml by 24ei. Right? Now if you are going to provide a unit moment here, you are going to get the rotation in this direction, right? You are going to get the rotation in this direction. So m if it is 1, theta at B due to unit load provided at C, that is 1. So that is F31 you are able to get, which is nothing but minus of L by 24ei. Minus already there, because the coordinate direction is given clockwise and you are getting the anti-clockwise rotation here, right? L by 24ei. If L is 6, 1 by 4, and it will certainly become minus 0.25 by ei. Did you get that? And F13 is equals to F13. F31 equals to F13. I can say that it is minus is also already there. But if it is not given in the question, option, I'll just go with the value which is given provided here. That is 0.25 by EI. Are you able to understand that? Yes, PM. I have used the rotational stiffness. I have used the rotational stiffness to get the. I hope you are enjoying this, isn't it? Now, next one. What will be the value of K11? What will be the value of K11? What will be the value of K11? What is the meaning of K11? If you are providing a unit rotation here, to produce a unit rotation at joint B, as it looks like it is a rigid joint, so if you want to produce the unit rotation, of course, how much effort you need to apply, that is quite easy, very easy. Best easy problem all of. So here, how much effort you need to apply, that's the meaning of K11. If you want to produce a unit rotation here, what is the force? So to produce a unit rotation here, you need to provide 4 EI by L, correct or not? And for this one, far end is hinged, so here you need to apply, that is 3 EI by L, 3 EI by L. Three EI by L, 3 EI by L. So total effort you need to apply is nothing but 7 EI by L. That's all. Do not miss tomorrow's session. Those who are watching this, ILD influence line diagram. I used to teach influence line diagram with the help of the model which I have. That is one of the fantastic thing I have. I made it from myself. So morning, please meet me for the influence line diagram at 11 a.m. Then we will solve some problems on YouTube at 9 p.m. Do not miss any of the session for the ILD. Either it is for determinate or for the indeterminate one. We'll be seeing the ILD for truss also. All of you, do not forget also to hit the like button and do not forget to share with your friends. So let us meet for influence line diagram. Till then, good night everyone. Meet me, yes, at 11 a.m. on app, BYJU'S app. Thank you and good night. ट्रस का क्लास हुआ ना? ट्रस का मैंने प्रॉब्लम बाद में दूसरे दिन लिया था ना? कल ही तो लिया शायद मैंने. कल के क्लास में ही तो लिया ट्रस का कुछ ज़्यादा प्रॉब्लम. थैंक यू एवरीवन. गुड नाइट.